Okay, so welcome back. We're going to start taking notes on section 7.1. So chapter 7 is all about polygons, and specifically in chapter 7.1, we're talking about applications of some triangle theorems. So the first theorem is theorem 50. I know you guys love your theorems, and if you take a look at this, you already know it. Okay, so you guys already know theorem 50. Theorem 50 says that if you have a triangle, that the three angles in the triangle, so angles A, B, and C, the measure of angle A plus the measure of angle B plus the measure of angle C is always going to be 180 degrees. Okay, so again, the three angles of a triangle will always add up to 180 degrees. I know we already know this. The next theorem that we're going to get to has to do with exterior angles. So if you take a look at these, when we're looking at exterior angles, this is the definition. Okay, so the exterior angle of any polygon, not just a triangle, but any polygon, is an angle that's adjacent, again, which means next to, and supplementary. Okay, so again, it's supplementary and next to one of the interior or inside angles. So if I'm just zoning in here, this is one of my inside angles. Okay, this angle right here is next to the pink angle, and it's also supplementary to it. So we consider that an exterior angle. So I understand that if I were to extend this line, okay, this is my exterior angle. Again, it's supplementary to the interior angle. Okay, and it's adjacent to it. So that is considered an exterior angle. Now watch this. I can also draw one this way. Okay, so again, this is considered an exterior angle, and this is my interior angle. Okay, so we have our exterior angles. We can find out some good information, and this is true for any polygon, and so that's why we didn't just put triangles in here. So again, this is my interior angle. So if I extend this line, this is my exterior angle. It's next to exterior, it's next to the interior angle, and it's also supplementary to it. Which brings me to my next point. So again, we're specifically dealing with triangles in section 7.1. We're gonna put some numbers to some things. So hypothetically, let's pretend that, I don't know, this is 60 degrees and this is 40 degrees. Okay, if we know two angles in a triangle, it's really easy for us to figure out the third interior angle by using theorem 50. It says that these triangles add up to 180, which would make this angle right here 180 degrees. Now, if that's 80 degrees, sorry, if that's 80, angle 1 has to be supplementary to that, which would make angle 1 100 degrees. Now, you should start to look at this. Oh, look, wait a minute. That's weird, because if I add those two purple ones up, it's equal to that green angle. Hey, Miss Botica, does that always work? Well, let's try another one. Let's do two purple angles. We'll do 30 and 20 because those look pretty small. Now again, 30 and 20, okay, these two angles over here, again, those are the two remote angles. We call these the remote angles. We've talked about these before. They are not touching the exterior angle, okay? Those are my remote angles. So 30 and 20 add up to 50, which makes this blue angle 130. And then wait a minute, angle 1 is 50. That's crazy because these two purple angles add up to 50. Does that always happen? It absolutely does. So if you were to know two angles, any two angles, so I'm just going to do, I don't know, what do you want to do? B and C? Good, like you guys are talking to me. Let's pretend this is 40 degrees and this is 30 degrees, okay? If you were to build any exterior angle off of A, that angle would be equal to the sum of those two angles. So that has to be 70 degrees. It has to. I don't care if you went the other way, which actually, if you went the other way, if you went the other way, keep in mind that that's vertical with with this way. So again, this would have to be 70. This exterior angle would also have to be 70. Okay, and I know that because when you add those two angles together, it equals 70, which makes this angle 110. And when you build this exterior angle off of it, it has to be supplementary. Okay, so this exterior angle is going to be equal to those two remote angles. Okay, so again, let's do this. We have A, B, and C. Okay, the measure of an exterior angle of a triangle is equal to, so I'm going to extend this and I'm going to call this angle 1. So the measure of angle 1 is equal to the sum of the measures of the remote interior angles. Fancy word for the two inside angles that are not touching angle 1. Okay, is angle C touching angle 1? Yes, it is, because this is talking about angles A and angle B. So this exterior angle will equal angle A plus angle B added together. Okay, so theorem 50, all three angles add up to 180. We use that to prove theorem 51, which says that the exterior angle is going to add up to the two remote, or the two angles that are inside the triangle that are not touching the exterior angle. And then my last theorem, before I get into the examples, is called the Midline Theorem. Okay, I'm going to highlight this. The Midline Theorem. And this is a lot of information. A segment joining the midpoints of two sides of a triangle. Okay, so H is the midpoint of GJ, and M is the midpoint of GK. Okay, if there's a segment drawn from H to M, every single time, that segment is not only going to be parallel to the third side, but it's actually also going to be half as large. So if this is 10, this would have to be 5. There's actually a really cool proof with this where you extend this, making this the additional 5 right here, and going like this. And so what happens is this is congruent to this, and you get some congruent triangles working here. If you see the vertical angles, you get your congruent triangles. And so what happens is this side over here ends up being congruent to this side over here, making this a parallelogram. And if it's parallelogram, the opposite sides are parallel. I know you guys are super interested in that, but it's really cool to see how mathematicians actually proved this theorem. But this is called the Midline Theorem. So if you see lines drawn like that, from the midpoint of one side to the midpoint of the other side, that means that not only is HM parallel to JK, it means that half of JK is equal to HM. Okay, and we can try this again. I'll draw another little triangle here. I'll call this super unique ABC. So once again, you know what? Let me draw like an obscure. I'm going to draw some like crazy triangle, like these kind of long-ish. I wasn't videotaping this. It would probably go perfectly. Okay. So what I'm going to do is I'm going to connect the middle of, what do you want me to do? The middle of this blue side. Okay, so the middle is right here. And I will connect it to the middle of, let's do the bottom side. We'll find the middle of the bottom. So that looks like it's right about here, okay? If I connect these two middles, this is the middle, and this is the middle, middle 1 and middle 2. If I connect these, this segment is very special, okay? It is not only going to be parallel to this third side, it's also half as large. So hypothetically, if this was 4, this segment down here has to be 8. Okay, that's the midline theorem. You can do these, you can connect all the midpoints if you wanted to, and we're going to talk about that. But again, look at this. So this green segment is parallel to this pink segment, and it's also half as large. So hypothetically, if this pink segment was 14, this green segment would be 7. And then, of course, you can connect this last one right here. Again, parallel to the blue side. I hope you notice that there's some congruent triangles going on here. We can prove which triangles are congruent. And there's a lot of information to pull from this theorem. Okay, so again, that's called the midline theorem.